Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad BUKHARY BUKHARY and my group member ZETTY RANIA, Hasyiemie and MOHAMAD AIMAN. We are from group 6 and we will present the topic power transformer. Before we go deeper into this topic, let me introduce what is power transformer. Power transformer is one type of transformer that is used to transmit electrical energy in any component of the electrical between the distribution primary circuit and the generator. Power transformer works on the principle of Faraday's law. Let's we look at into this picture. From power plant, engineer want to transfer 12 kilovolt to the consumer. Let's say the distance from power plant to consumer is about 300 kilometer, and we only use wire to transfer 12 kilovolt. What will happen? Due to huge distance and heat loss from wire, the voltage will drop and the consumer will not receive the required amount of voltages. To control this, engineers invent power transformer so that they can increase voltage to prevent heat loss and decrease it back to the voltage to give to the consumer. From 12 kilovolt, they step up to 400 kilovolt and by using a step-up transformer. And from 400 kilovolt, they step down to 13 kilovolt by using a step-down transformer. And they step down again to 240 volt so that the consumer receive the perfect amount of voltages. Of course, there's advantage and disadvantage for the power transformer. First advantage is it is useful in stepping up or down the voltage, means engineer can control how much they want to transfer and transmit the voltage. Second, the durability for power transformer is between 25 and 40 years because power transformer doesn't require any mechanical movement. And third, it is highly efficient with less capital investment and low maintenance. For the disadvantages, due to its material in making of the iron core, there is wastage in the current flow. And second advantage is it gives out a lot of heat which requires cooling. This will create a break in the flow of the current.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad RASYIDI and my metric number is 2017115. So for my part, I will explain about the basic principle and operation of this power transformer. First of all, we must know that the power transformer operates on the principle of Faraday induction law. The law indicates that once a closed loop is brought near a fluctuating magnetic field, then the current flowing is produced in that closed loop. This means that the magnetic field that cut the loop must keep changing in order to produce a current flow. The varying magnetic field will generate the EMF across the loop. So in order to describe the law better, let us go through this figure. First of all, consider that a conductor and a permanent magnet are brought near to each other initially. Then the conductor is short circuit at both sections employing a wire as presented in the figure. In this case, there will be no current flowing through the conductor or in the loop since the magnetic field cutting the loop is constant. As stated in the law, just a varying magnetic field can force current in the network. So, in the first figure of the constant magnetic field, there will be no current flow in the loop or the conductor. Moving on to the next figure in the slide. Now consider if the magnet is sliding back and forth, such as a pendulum. Then the magnetic field cutting the conductor has variation. Because there is a modifying magnetic field available, Faraday law will result in, and thereby we can see a current moving in the loop. As presented in the figure, after the magnet slides forward and back, we can see the current I moving across the closed loop and the conductor. So for more practical operation of Faraday's law, we can use a coil on both sections. Now, an alternating voltage source and a conductor are used to produce a varying magnetic field. After the loop is brought close to the magnetic field range, then an EMF generated through the conductor can be seen. So due to this stimulated EMF, we can have a current flow I. The magnitude of the stimulated voltage is directly proportional to the field strength experienced by the secondary loop. So the greater the magnetic field strength, the larger the current flowing in the closed loop. Here we can see an alternating current move across the first primary coils that produce the modifying magnetic field near the conductor coils. Then, when the second coil enter in the rating of the magnetic field produced by the first coil, an EMF is created across the second coil due to the Faraday induction law. Then, due to the produced voltage in the second coil, a current flow within the secondary closed network. So next, as we can see in the third figure, both coils are hanging in the air. So the medium conduction applied by the magnetic environment is the air. So the air has greater resistance in comparison with metal in the case of magnetic field condition. So if we employ a metal core to perform as a medium for electromagnetic network, then we can obtain an electromagnetic induction more effectively. So to fix that, we can apply an iron core to drop the magnetic flux waste during energy transmission from one coil to another one. During this time, the magnetic flux waste into the atmosphere will be less than the time we apply a medium as a gap in the conductor of the magnetic field. So I think that's all for my part. Now I will pass the presentation to the next presenter.
So this is the basic equivalent circuit for the step-up and step-down transformer. As you can see here, the number coil turns will affect how transformer work. In step-up transformer, the input has few turns compared to the secondary output. The result for the step-up transformer is that the voltage will increase and current will decrease in the output. For the step-down transformer, the input have many turns compared to the output. Because of this, the voltage decreases and current will increase.
Hi, Assalamualaikum. My name is RANIA and I am going to talk about the types for power transformers. So power transformers can be further be classified into three categories depending on the power rating, which is small power transformer, medium power transformer, and large power transformers. So the rating for a small power transformer can be more than 30 volt ampere to 500 or 700 kV ampere, or in some cases that can be equal to or more than 7,000 kV ampere. For the medium rated power transformer, they can be up to 50 to 100 megavolt ampere, whereas for large rated power transformers, they are capable to handle more than 100 megavolt ampere. Next, there are two types of transformer that is based on voltage level, which is one step-up transformer and the second one is step-down transformer. The step-up transformer is to transform the low voltage and high current input from the primary section of the transformer into the secondary section of the device to high voltage and low current value. The step-down transformer is to transform the high voltage and low current value from the primary section to low voltage and high current output on the secondary section of the device. So far we have talked about type of transformer based on voltage level and types of transformers based on power rating. And next we're going to generally talk about types of transformers that are out there, which is electrical slash power transformer, measurement transformer, and distribution transformer. For your information, all types of transformers, they follow the same principles, but they have different construction methods. That's what they are. There are so many types of transformers, the way they are winded, the arrangement of the power transformer, also the core, the type of core they use, so that the construction method is different, so that brings up different types of transformers. So for now, we're going to talk about electrical transformer, which is also the same as power transformer. They are typically employed in transmission applications for stepping down or stepping up the voltage rating, and it performs mostly during peak or high loads and has maximum efficiency at or near the entire load. Up next is the distribution transformer, which is used to step down the output for distribution cases to commercial or domestic consumers. Because from the power transformer, they have like very big output, so they have to step down the output so that it is suitable for domestic consumers like houses or shops, and it has appropriate voltage regulation and performs 24 hours a day with maximum efficiency at 50% of a complete load. Next, we have instrument transformers, or can be called as measurement transformers. They contain both current transformer and power transformer, and its function is to drop high voltages and current to lesser outputs, which can be controlled by conventional devices. Lastly, we're going to talk about the transformer types based on winding arrangement. So there are two of them, which is two-winding transformer and the most popular one, the auto transformer. So the difference between both of them is that the two-winding transformer is especially used where the difference between low voltage and high voltage is higher than 2. And when the ratio between the different side is less than 2, it is more efficient to use an auto transformer. So as the picture given on the slide, as you can see, the difference between the two-winding transformer and the auto transformer, where the auto transformer, the primary and the secondary coil is reconnected as a series. So that's all for types of transformer. And that's all from me. Thank you.
Assalamualaikum. My name is Faezzal Hasyiemie, and for my part, I'm going to explain about the single-phase and three-phase transformer. So first, we already learned about the single-phase power supply and three-phase power supply and how they differ from each other. So just like power supply, transformer also have the variation of a single-phase transformer and three-phase transformer. Okay, so most of us are most probably familiar with this one. One iron core, winded with primary coil on one side and secondary coil on the other side. So when there's only one pair of this primary and secondary coil, we know this as a single-phase transformer. Depending on the ratio of the coil, it can either be a step-up or step-down transformer. But either way, we can only get single-phase power supply from this transformer. It is impossible. We cannot get a three-phase power supply from a single-phase transformer. So usually we only use this single-phase transformer for lower power requirement devices. For example, our house. Even though the power supply we receive in our house already been stepped down from the distribution grid, it is still quite high for normal devices usage. So each of our electrical appliances, for example our mobile charger, have a transformer inside them to step down the power to maybe 10 volt or 5 volt as needed. But basically the transformer used in these lower power devices is the single phase transformer. Compared to that, this is how a three-phase transformer looks like. This basically, if single-phase transformer have one set of the primary and secondary coil, three-phase transformer have three set of those. It can either be one iron core and winded with the three set of the coil, or it can be three single-phase transformer banked together. So there are many ways to configure the coil or to bank the three single-phase transformer together, but not limited to, but usually we use this delta delta, delta y, y or y delta configuration. So the output, there might be variation in the output depending on how we configure the three-phase transformer. So we can get a three-phase power supply from this transformer, but we can also get single-phase power supply from this if we wanted to. And the three-phase transformer have higher efficiency if we compare it to the single-phase power supply. So as we can see, since we know that our power supply system, we use three-phase power supply instead of the single phase. So obviously we're gonna need three-phase transformer inside this instead of the single phase, because single phase cannot output a three-phase power supply. So for the transmission grid, we use three-phase transformer. For inside the house, we use the single phase. To reiterate, this is the comparison table between the single phase transformer and the three-phase transformer. We have the set of primary coil, single phase have 1, three-phase have 3, input and output terminal. So for a single phase transformer, we have 2 input terminal and 2 output terminal, which is 1 phase and 1 neutral. For the three-phase transformer, we have 3 input terminal, since 3 set of wire, and 3 output terminal. But it might also be 4 output terminal if we have the neutral terminal. This is depending on the configuration. If we use delta delta, delta y, etc., it can have different output. So for a single phase transformer, it can only output a single phase load, but for three-phase transformer, we can output both single phase and three-phase, if we have whichever we need. For the cost, single phase transformer is obviously cheaper compared to three-phase, but in the long run, three-phase transformer will be better economically because it have higher efficiency. Okay, I think that's all from me for my part. And that's the whole for our group. Thank you.